Have you ever stopped to think about how your phone unlocks just by looking at you, or how a car can drive itself down a busy street? Well, the magic behind all of that is a field of AI that's teaching machines a skill that is, fundamentally human, how to see. So let's pull back the curtain and really dive into the amazing world of computer vision.
Okay, so when you and I look at this picture, our brains just instantly see it, right? Cars, lanes, trees, the road, we get it. But for a computer, it's a totally different story. It doesn't see a car. It sees a massive grid of pixels, millions of tiny little dots, each one with a specific color value. To the machine, it's just a sea of data with absolutely no meaning.
So that's the big question, isn't it? How do we possibly bridge that gap? How do we teach a machine that a certain cluster of pixels is a car and another one is a stop sign? Well, the answer lies in a really powerful corner of artificial intelligence.
And that corner is called computer vision. Now, this isn't just about teaching a computer to record an image, like a camera does. No, this is about teaching it to truly understand it, to interpret, to analyze, and to pull out meaningful information, pretty much just like our brains do.
And believe me, this isn't some far-off science fiction. This stuff is already woven into the fabric of our daily lives. So let's take a look at how this technology is reshaping our world, right now.
Let's start with self-driving cars. Their eyes are this whole suite of cameras and sensors, and it's all powered by computer vision. It's what lets them make sense of the, frankly, chaotic world around them. And this isn't an all-or-nothing kind of thing. We're actually moving up these levels of automation, from basic driver assistance that many of us have today, all the way to the ultimate goal, a car that drives itself completely. Computer vision is what's pushing us up that ladder.
And the potential here is massive, way beyond just convenience. I mean, just imagine cities with less traffic, cleaner air, lower transportation costs for everybody. Picture all those parking lots turned into parks and playgrounds. That's the kind of future that autonomous vehicles powered by computer vision could actually unlock for us. In fact, you probably use computer vision every single day without even thinking about it. I'm talking about facial recognition. It's the tech that unlocks your phone in a split second. But it's also making airport security faster, helping out law enforcement, and even making sure the right patient gets the right care in hospitals. It's kind of becoming this silent, secure partner in our daily routines. Computer vision is also the engine that's powering the next big thing in how we interact with technology, immersive experiences like augmented and virtual reality. Because think about it, to either add a new layer to our world or to create a whole new one, a machine first has to understand the physical space we're in. The difference between the two is actually pretty simple. Augmented reality, or AR, adds a digital layer on top of your world. Think of those social media filters or games where it looks like a character is right there in your living room. Virtual reality, VR, does the exact opposite. It creates a brand new, completely simulated world that you step into, leaving the real one behind. But maybe the most profound, the most life-changing impact of computer vision is happening in healthcare. We can now train algorithms on millions of medical scans, teaching them to spot things like cancerous cells with, frankly, superhuman precision. They can see these tiny, subtle patterns that might be invisible to the human eye, giving doctors an incredible new tool and giving patients a much better chance.
Okay, so how does this actually work? I mean, how do we go from a bunch of pixels to actual perception? Well, it all starts with building a digital brain from the ground up.
At the very heart of it all is the artificial neuron. The best way to think of it is like a tiny decision maker. It takes in a bunch of information, it weighs how important each little piece is, and then it makes a super simple choice. Is this signal strong enough to pass along? If the answer is yes, it fires and sends that message on to the next neuron in the chain.
Now, one neuron on its own isn't very smart, and this is where the magic happens. When you connect millions or even billions of them together in layers, you get something incredibly powerful, an artificial neural network. This is the structure that can actually learn to recognize all those complex patterns in the data.
And learning is really just a process of trial and error, but on an absolutely massive scale. You show the network an image, let's say of a cat. It makes a guess, you tell it if it was right or wrong. And based on that feedback, it slightly adjusts the strength of the connections between all its little neurons. Now do that millions of times with millions of different images, and gradually through all those tiny corrections, the network becomes an expert at recognizing cats.
But here's the thing, not all of these digital brains are built the same way. It's kind of like a carpenter's toolkit, right? You have all these specialized tools for different jobs. You wouldn't use a hammer to saw a piece of wood. You got to pick the right tool for the task.
So when the job is to understand a single static image, like finding a car in a photo, the go-to tool, the expert in the field, is the convolutional neural network, or as everyone calls it, a CNN. Think of it as a specialist, designed from the ground up just to make sense of pixels.
So how does a CNN work? This is so cool. Imagine it's looking at an image, but through a bunch of special magnifying glasses called filters. One filter is an expert at finding horizontal edges. Another one only looks for curves. A third one might be a pro at spotting certain textures. The CNN slides these filters over the whole image, basically making maps of where it finds these simple features. Then, in the next layer, it learns to combine those simple maps, like, oh, this bunch of edges and curves looks like an eye, until it can recognize the whole complex object.
Okay, but what about when the data isn't just a static picture? What about things that happen over time, like all the frames in a video or the words in a sentence? For that, we need a different tool from our toolkit. We need one that has a sense of memory.
And that tool is the Recurrent Neural Network, or RNN. Its secret weapon is that feedback loop you see there. What that means is as it's processing new information, it's also remembering what it just saw. It's not just looking at the current frame of a video, it's looking at it in the context of the frames that came right before. It gives it a kind of short-term memory.
And that memory is absolutely crucial for any task where context is king. I mean, think about speech recognition. The meaning of a word totally depends on the words that came before it. Or predicting where a car is going. You have to know where it's been. That is where RNNs are the star of the show.
So let's just step back for a second. We've taught machines to see, to recognize objects, and even to understand context over time. This is so much more than just a cool technical achievement. It has really profound implications for all of our futures.
And this, to me, is the most exciting part. The real power of computer vision isn't just about mimicking what our eyes can do. It's about creating a totally new kind of perception. A system can analyze thousands of medical scans in the time it takes a doctor or two to look at one. It can monitor an entire factory floor for safety issues all at once. It can spot these critical patterns that are completely invisible to the human eye.
Which really leaves us with this one profound question. We have given machines the gift of sight. The possibilities are almost limitless. And this journey, it's really just getting started. The question is no longer if machines can see, but what will we as their creators choose to show them next?